All right, so we've got this PDF. Someone sent us algorithms notes, o.pdf, and wow, at first glance, this thing looks intense.
Yeah, it's a bit of a beast, isn't it?
200 pages, all about algorithms.
It's a lot to unpack.
It really is. But I think it's going to be worth it. I mean, this looks like the key to understanding, like, how the entire digital world works.
I agree. It's like this hidden language that's running everything behind the scenes. And once you start to understand it, well, it's like you've got this secret decoder ring.
Exactly. So where do we even begin?
Well, I think a good place to start is by answering the most basic question. What exactly is an algorithm?
Yeah, we throw that word around a lot, but do we really know what it means?
Well, at its core, an algorithm is simply a set of instructions for solving a problem. You take some input, you process it through a series of steps, and then you get an output.
So it's like a recipe.
Exactly. A recipe is a great analogy. You have your ingredients, which are your inputs, and then you have your step-by-step instructions, that's your algorithm. And then finally, you have your delicious meal, which is your output.
I like that. Now, algorithms notes, OOL.pdf, uses these terms instances and outputs. What do those actually look like in a real-world algorithm? Can you give me an example?
Sure. Think about something like a vending machine.
Okay.
You put in your money, that's your input or your instance. The machine then uses an algorithm to figure out what you've selected based on the buttons you press, and then dispenses your snack. That's the output.
Okay, so the money I put in and the buttons I press, that's the input, and then the snack that comes out, that's the output.
Exactly. And the algorithm is what connects those two things. And it's not just vending machines. Think about something like searching for something online.
Okay, so I type something into Google.
Right. You type in a search query. That's your input. Google's algorithm then goes to work, sifting through billions of web pages to find the most relevant results and then presents those to you. That's the output.
And that happens in like milliseconds.
Exactly. Algorithms are designed to be efficient, and they're everywhere.
It's incredible when you think about it. Speaking of algorithms, this algorithms notes, oo.pdf, mentions something called FizzBuzz. That sounds more like a kid's game than a core concept in computer science. What is that all about?
You'd be surprised how often FizzBuzz comes up, even in serious programming interviews. It's a simple but surprisingly effective way to illustrate how algorithms work.
Okay, I'm intrigued. So how do you play algorithmic FizzBuzz?
Well, imagine counting from 1 to 100, but every time you hit a multiple of 3, you say sizz. For multiples of 5, you say buzz. And if a number is a multiple of both 3 and 5, you say FizzBuzz.
So 1, 2, fizz, 4, buzz, fizz, 7, 8, FizzBuzz.
You got it. It's like a fun little brain teaser, but it actually demonstrates some fundamental programming concepts like loops and conditional statements.
Yeah, exactly. And what makes it an algorithm is that you're not just saying these words randomly. You're following a specific set of rules. It's like you're giving the computer a set of instructions that it can follow to produce the desired output.
So you're basically teaching the computer how to play FizzBuzz.
Exactly. You tell the computer to start at 1 and then check if that number is divisible by 3.
If it is, you say.
Fizz.
Right. And if it's not, then you check if it's divisible by 5. If it is, you say buzz. If it's divisible by both 3 and 5, you say FizzBuzz. Otherwise, you just say the number itself. And then you move on to the next number and repeat the process.
Okay, so it's all about setting up these little decision points within the algorithm. If this, then that. Otherwise, do this.
Exactly. And Algorithms Notes so.pdf goes into a lot more detail about how these conditional statements and loops work, but FizzBuzz is a great way to start wrapping your head around the basic logic.
It is. It's like a gateway algorithm.
Exactly. Now, Algorithms Notes so.pdf dives into a whole bunch of different types of algorithms. One that I thought was particularly interesting was sorting algorithms.
Sorting algorithms. I mean, that sounds pretty self-explanatory. You're just putting things in order, right?
Well, it sounds simple, but it's actually a lot more complex than you might think. And it's incredibly important for all sorts of things.
Like what?
Well, think about something like searching for a flight online. You want to be able to sort those flights by price.
Right.
Or by departure time, or by the number of stops.
Right, so you don't have to scroll through like a million different options.
Exactly. Or think about organizing your music library. You might want to sort your music by artist, by album, or by genre. All of that requires sorting algorithms.
So how do they actually work? What are some of the ways you can sort things in the world of algorithms?
Well, one way is called bubble sort. It's pretty straightforward. Imagine you have a list of numbers that you want to sort in ascending order.
Okay.
Bubble sort works by repeatedly comparing adjacent elements in the list and swapping them if they're in the wrong order.
So if you have 5 and 3 next to each other?
Exactly. You'd swap them so that 3 comes before 5. And you keep doing this, going through the list over and over again until everything is in its correct sorted position.
Sounds kind of tedious. Like, is that really the most efficient way to sort things?
It's definitely not the most efficient, especially if you have a really long list. It's actually one of the slowest sorting algorithms out there, but it's a good one to start with because it's easy to understand.
So what's a faster way to sort things?
Well, Algorithms Notes loans Quicksort as a much faster option. It's a more complex algorithm, but it's also much more efficient, especially for larger data sets.
So if you had, like, a million things to sort, you'd probably want to use Quicksort instead of Bubble Sort.
Exactly. Quicksort is actually used in a lot of real-world applications where speed is critical, like database management and search engines.
Makes sense. Time is money, after all. So besides Bubble Sort and Quicksort, what other sorting tricks does this Algorithm Notes PDF reveal?
Well, it also talks about insertion sort, which is kind of like how you might sort a hand of cards.
Okay, how so?
You start with one card in your hand, and then you take the next card and insert it into its correct position relative to the cards you already have.
So I get dealt a 4 and then a 7 and then a 2. I'd put the 2 before the 4 and the 7 where it was.
Exactly. And you keep doing this for each new card that you get. It's actually a pretty efficient algorithm for smaller data sets or for lists that are already partially sorted.
So each of these sorting algorithms has its own strengths and weaknesses depending on the situation.
Precisely. And that's one of the key takeaways from Algorithms Notes, oat.pdf. It's not just about knowing one algorithm. It's about understanding the different types of algorithms that are out there and knowing which one is best suited for a particular task. It's about choosing the right tool for the job.
It's like having a whole toolbox full of different sorting tools. You wouldn't use a hammer to tighten a screw. So we've covered a couple of specific examples here, FizzBuzz and sorting algorithms, but it seems like this document is about so much more than that. I mean, algorithms are everywhere, right?
They really are, and they're only becoming more ubiquitous. Think about all the ways that algorithms are used in our daily lives, from recommending products to us online to filtering spam from our inboxes to even driving our cars.
It's pretty incredible when you really stop and think about it. It's like this whole hidden world of algorithms that's quietly shaping our experiences every single day. And we're just talking about like the tip of the iceberg here, right? This Algorithms Notes, Zeus.pbf. It's like it's hinting at this whole other level of complexity.
Oh, absolutely. There's so much more to explore. Like, did you know that algorithms are being used to, like, predict natural disasters?
No kidding.
Yeah, and, like, plan the optimal routes for deliveries. They're even helping to decipher the human genome.
It's mind-blowing when you really think about it. Like these algorithms, these sets of instructions, they're not just like making our lives a little bit easier, they're tackling some of the biggest challenges.
Yeah, and that's what makes this whole field so exciting. It's like this incredible power that we're just starting to tap into.
It's like having a superpower.
Yeah.
You know, this ability to take these massive amounts of data, run them through these algorithms, and come up with these really meaningful solutions. But like with any superpower, I guess it comes with great responsibility, right?
Yeah, exactly. And Algorithms Notes Bo.pdf touches on this a little bit. Like, we have to be mindful of how these algorithms are being used. We have to make sure that they're being used ethically and responsibly.
That's a whole other conversation.
Yeah.
Like, how do we make sure that these algorithms are designed in a way that benefits everyone, that they're not biased?
It's a huge challenge, and it's something that we need to be thinking about a lot more as we become more and more reliant on algorithms.
So what can we do? I mean, most of us aren't going to become programmers or anything.
True, but you don't have to be a programmer to understand the basics of how algorithms work. And I think just having that basic understanding is so important.
Yeah, like knowing what's going on behind the scenes.
Right. It's about being an informed citizen of the digital age so that you can make more conscious choices about how you interact with technology.
That's a good point.
And, you know, there are tons of great resources out there if you are interested in learning more about algorithms.
Yeah, like where should we start?
Well, this Algorithms Notes or.pdf is a great starting point, even though it is a bit dense, like we said. But there are also tons of online courses, tutorials, books, you name it.
So it's not like this impossible thing to learn.
Not at all.
Okay.
And the more people understand about algorithms, the better.
Well said. Well, I think that's a good place to wrap things up for today. We've covered a lot of ground in this deep dive. We talked about what algorithms are, how they work, and why they're so important. We even got a little philosophical there at the end, talking about the ethical implications of algorithms.
It's all connected.
It really is. So, to our listeners, we hope you've enjoyed this deep dive into the fascinating world of algorithms. We encourage you to keep learning, keep asking questions, and keep exploring. Until next time.
See you next time.